So today we're going to work on section 1, lesson 2 of the making of a scientist. Now, if you haven't gone through and finished lesson 1, you need to go back and do that. And that means actually watching the video and answering the question, not just sitting there on the question screen for an hour and a half. I can see what you're doing. Anyway, today we're going to reread a portion of The Making of a Scientist with a partner who's going to be me. And we're not going to do the workbooks because I've decided workbooks are stupid and we're not using them. So, the big culminating writing task, the essay that we are building up to for this unit is, how does the process of scientific inquiry lead to the development of advanced technology? Now, even to me, that sounds like a lot of mumbo jumbo. So we need to break down what that actually means. So, scientific inquiry is basically the scientific method. It is what scientists use to ask questions about the world around them and then perform experiments to get their answers. So, how does this process of asking those scientific questions lead to better and better technology? While we are reading, we're going to read paragraphs 1 through 6. So, while we are reading, I want you to really be focusing on what was Feynman's father trying to teach him with the dinosaur example. Now, with this article, it's not just the facts that he's learning from his father. There's bigger lessons in there that he is learning. So I want you to see if you can try to pick that bigger lesson out. So here we go on the making of a scientist. Before I was born, my father told my mother, if it's a boy, he's going to be a scientist. When I was just a little kid, very small in a high chair, my father brought home a lot of little bathroom tiles, seconds of different colors. We played with them, my father setting them up vertically on my high chair like dominoes, and I would push one end so they would all go down. Then, after a while, I helped set them up. Pretty soon, we're setting them up in a more complicated way. 2 white tiles and a blue tile. 2 white tiles and a blue tile, and so on. Now, what is that called when you repeat a set of instructions over and over again? 2 white, then blue. 2 white, then blue is called a pattern. When my mother saw that, she said, leave the poor child alone. If he wants to put a blue tile, let him put a blue tile. But my father said, no, I want to show him what patterns are like and how interesting they are. It's a kind of elementary mathematics. Now, Richard Feynman's father was not talking about sending him off to elementary school while he was a baby in a high chair. Elementary in this case means basic. If you were to go to one of the preschool rooms or the kindergarten rooms, you would see that during math time, one of the first things they learn how to do is to repeat patterns. Math is full of patterns, and so we need to learn what patterns are before we can figure out what they look like. So he started very early to tell me about the world and how interesting it is. We had the Encyclopedia Britannica at home. When I was a small boy, he used to sit me on his lap and read to me from the Britannica. We would be reading, say, about dinosaurs. It would be talking about the Tyrannosaurus rex, and it would say something like, this dinosaur is 25 feet high and its head is 6 feet across. My father would stop reading and say, now let's see what that really means. That would mean that if he stood in our front yard, he would be tall enough to put his head through our window up here. We were on the second floor. But his head would be too wide to fit in the window. Everything he read to me, he would translate as best he could into some reality. It was very exciting and very, very interesting to think there were animals of such magnitude, and that they all died out, and that nobody knew why. I wasn't frightened that there would be one coming in my window as a consequence of this, but I learned from my father to translate. Everything I read, I tried to figure out what it really means, what it's really saying. So let's go back to our slides. So, what was Feynman's father trying to tell him about the dinosaur? Now, of course, the immediate answer that everybody comes up with is that the dinosaur is 25 feet tall and 6 feet across. But was that really the only thing Feynman's father told him about that dinosaur? It wasn't. What did Feynman's father do when he told him the size of the dinosaur? He compared the dinosaur to something Feynman already knew, his house. So what did Feynman learn from this? Feynman learned to take something that he may not already understand, like the size of the dinosaur, and compare it to something he did, like the house. So, for example, if I said something was 5 feet tall, you would understand that because that's about as tall as you are. If I say something is about 6 feet tall, you would understand that because that's about as tall as Mr. Boston. But if I say something is 25 feet tall, everybody's really going to have a hard time picturing that because we really don't know off the top of our heads what 25 feet looks like. So Feynman's father knew this, and he compared the dinosaur with the house, something that Feynman could see and experienced every day. So, what part of the text exactly makes you think that? So, we need to go back to our text for this, and we need to look at these paragraphs right here, these two paragraphs. Now, of course, we have the obvious example. Now, let's see what that means. That would mean that if he stood in our front yard, he would be tall enough to put his head through our window up here. We were on the second floor. But his head would be too wide to fit in the window. But this text has other things that we can read in between the lines. We can make inferences about. Everything he read to me, he would translate as best he could into some reality. Now, Richard Feynman is not actually talking about translating like you would translate something from Spanish to English. He's talking about making it easier to understand. How did Richard Feynman's father make the dinosaur easier to understand? He compared it to what Richard Feynman already knew, the house. Also, if you go down here to paragraph 6, but I learned from my father to translate everything I read. I try to figure out what it really means, what it's really saying. So here we have 3 pieces of example of text evidence that we could use to back up our answer of how do we know that Richard Feynman's father was not just teaching him about this dinosaur? Well, there's the 3 right there. So, which sentence in the paragraph shows a point the author is trying to make? Now, we are not going to be looking at our super obvious example for this one. That would mean if he stood in our front yard. That's not really illustrating his point very well. If we look at our other 2 pieces of text evidence, everything he read to me, he would translate as best he could into some reality. But I learned from my father to translate everything I read. I try to figure out what it really means, what it's really saying. Those are 2 pieces of text evidence that better illustrates the answer to our question. Which sentence in the paragraph shows a point the author is trying to make? The author is not trying to make a point about a dinosaur. The author is trying to show us some of the lessons he learned from his father. And the main lesson he learned with the dinosaur is to compare things that you don't understand with something that you do understand. So it says, what does Feynman mean when he says that he was taught to translate? So take a minute, think about that. We just discussed it. What does it mean? So again, he is not meaning that he's literally translating something from one language to another. He is making something easier to understand. That is another definition of the word translate. So that leads us to the bird example. What was Feynman's father trying to teach him with the bird example? Well, to answer that question, we need to go back and we need to read the bird example. So let's go back. We're going to scroll down here. And we are going to continue on with our example. So we're on to the bird story now. We used to go to the Catskill Mountains, a place where people from New York City would go in the summer. The fathers would all return to New York to work during the week and come back only for the weekends. On weekends, my father would take me for walks in the woods, and he'd tell me about interesting things that were going on in the woods. When the other mothers saw this, they thought it was a wonderful idea and that the other fathers should take their sons for walks. They tried to work on them, but they didn't get anywhere at first. They wanted my father to take all the kids, but he didn't want to because he had a special relationship with me. So it ended up that the other fathers had to take their children for walks the next weekends. The next Monday, when the fathers were all back from work, we kids were playing on a field. One kid says to me, "See that bird? What kind of bird is that?" I said, "I haven't the slightest idea what that kind of bird that is." He says, "It's a brown-throated thrush. Your father doesn't teach you anything." But it was the opposite. He had already taught me. "See that bird," he says? "It's a Spencer's warbler." I knew he didn't know the real name. Well, in Italian, it's a Ciurla In Portuguese, it's a Bom de Pita. In Chinese, it's a Chonglong Ta. And in Japanese, it's a Katano Takita. You can know the name of the bird in all the languages of the world, but when you're finished, you'll know absolutely nothing whatever about the bird. You'll only know about the humans in different places and what they call the bird. So let's look at the bird and see what it's doing. That's what counts. I learned very early the difference between knowing the name of something and knowing something. He said, for example, look, the bird pecks at its feathers all the time. See it walking around pecking at its feathers? Yeah. He says, "Why do you think birds peck at their feathers?" I said, "Well, maybe they mess up their feathers when they're flying, so they're pecking at them in order to straighten them out." All right, he says, "if that were the case, then they would peck a lot just after they've been flying. Then after they've been on the ground a while, they wouldn't peck so much anymore. You know what I mean?" Yeah. He says, "Let's look and see if they pecked more just after they land." It wasn't hard to tell. There was not much difference between the birds that had been walking around a bit and those that had just landed. So I said, "I give up. Why does a bird peck at its feathers?" "Because there are lice bothering it," he says. "The lice eat flakes of protein that come off its feathers." He continued, "Each louse has some waxy stuff on its legs, and little mites eat that. The mites don't digest it perfectly, so they emit from their rear ends a sugar-like material in which bacteria grow." Finally, he says, "So you see, everywhere there's a source of food, there's some form of life that finds it." Now, I knew that it may not have been exactly a louse, that it might not be exactly true that the louse's legs have mites. That story was probably incorrect in detail, but what he was telling me was right in principle. Now, when we say the word principle, do you think we're talking about a principle like Miss Copeland's? We are not. We're talking about a general law or a larger truth. Some people say that they have principles, okay? It's rules that they follow, but it could mean rules that the world tends to follow as well. So we're going to go back to our slides. So what was Feynman's father trying to teach him with that bird example? Do you think that he was really just trying to teach him about why birds are pecking at their feathers? So think back to the dinosaur. Feynman's father wasn't just trying to teach him the basics about animals. There was some sort of larger lesson involved. So let's go back and let's try to figure out what this larger lesson is for this bird example. So we come to the explanation where he talks about the lice. And on the lice, there are mites, and the mites eat the waxy stuff on the lice's legs, and then the mites poop out the sugar stuff, and then bacteria grows in the sugar. Obviously, that's a really long explanation, but did he just give Feynman a simple answer? Did he just say, "Oh yeah, the bird is pecking at his feathers because lice"? He didn't. He took the time to explain. And then if we go to this sentence right here, that story was probably incorrect in detail, but what he was telling me was right in principle. Now, Richard Feynman knew that not all birds have lice on them, and that general food chain may not be exactly correct. But the lesson right here, so you see, everywhere there's a source of food, there's some form of life that finds it, is correct. That's the principle he's talking about. That's the rule. If there is food, there is going to be something that eats it. And then Richard Feynman's father, again, took the time to really explain that to Richard instead of just giving him some quick answer. So then what about the wagon example? All right, well, again, we got to go back to the story, the article, and we got to read about the wagon. So, with the wagon, it says, "My father taught me to notice things. One day I was playing with an express wagon, a little wagon with a railing around it. It had a ball in it. And when I pulled the wagon, I noticed something about the way the ball moved. I went to my father and said, Say, Pop, I noticed something. When I pull the wagon, the ball rolls to the back of the wagon. And when I'm pulling it along and I suddenly stop, the ball rolls to the front of the wagon. Why is that? That nobody knows, he says. The general principle, there's that word again. The general principle is that things which are moving tend to keep on moving, and things which are standing still tend to stand still unless you push them hard. This tendency is called inertia, but nobody knows why it's true. Now, that's a deep understanding. He didn't just give me the name. He went on to say, if you look from the side, you'll see that it's the back of the wagon that you're pulling against the ball, and the ball stands still. As a matter of fact, from the friction, it starts to move forward a little bit in relation to the ground. It doesn't move back. I ran back to the little wagon and set the ball up again and pulled it on the wagon. Looking sideways, I saw that indeed he was right. Relative to the sidewalk, it moved forward a little bit. That's the way that I was educated by my father, with those kinds of examples and discussions. No pressure, just lovely, interesting discussions. It has motivated me for the rest of my life and makes me interested in all the sciences. It just happens I do physics better. I've been caught, so to speak, like someone who was given something wonderful when he was a child, and he's always looking for it again. I'm always looking, like a child, for the wonders I know I'm going to find. Maybe not every time, but every once in a while. So, what was Feynman's father trying to teach him with that wagon example? Feynman asked his father about why the ball was moving. And what did Feynman's father tell him? You might have come up with the word inertia or remembered the general rule behind it, maybe not the word. Well, did Richard Feynman's father just go, oh, yeah, that's inertia, and then move on? He didn't. He took the time to really explain to Feynman about why the ball was moving in this wagon the way that it was. Again, this is another lesson he learned from his father. He learned to look for the deep understandings. So, obviously, we're not going to answer this question because there's no group, but I want you to take a moment. I want you to think about these examples, the dinosaur and how Feynman's father taught him to translate, the bird example and the principle that Feynman's father taught him with the bird, and then Feynman's father giving him those deep understandings. And I want you to really, really think before you go and answer your Google form question. What are these big lessons that Feynman's father is trying to teach Feynman? Feynman's father is trying to teach him to understand the world around him and to look and investigate for himself. So, more specifically, with the dinosaur, and if you haven't paid attention to anything else, I hope you pay attention to this because this is going to help you on your Google form. With the dinosaur, remember, was he just trying to teach Feynman that the dinosaur was 25 feet tall and 6 feet across? No. He was trying to teach Feynman to compare something he didn't know to something he did know. So go to your Google form, answer your question. I want complete sentences, and then finish that list on Google Classroom and go back and finish any of the assignments you haven't finished already. I miss you, bud. I'll see you soon.